Hi, I'm Lester Knutsen, and welcome to my Tech Talk on exploring the Informix SysMaster database. This is pre-recorded, but please mute your lines because background noise will distract everyone. If you have questions, use the chat button to ask your questions. Since it's pre-recorded, I'll be monitoring the chat and we'll try and answer your questions as best I can. I've been working with Informix for over 40 years, since 1983. I'm retired now, but it's been a long and wonderful journey with one of the best databases in the world. So what is a SysMaster database and why is it important? The SysMaster database is a SQL structure that is a peek into shared memory. I don't know if you remember back in the old days of basic programming where you did peeks and pokes into memory. The SysMaster database is like a peek into shared memory. When you start up an Informix server, right at the first thing that happens is these control structures get created, and the control structures are C-list that are very dynamic because they monitor what's going on. They're counters. Every time a page gets read, a counter gets incremented. Every time a user logs on, something gets incremented there. The SysMaster database is an SQL structure that allows you to read those control structures. Now, it's the same data as OnStat. If you do an OnStat-P, you can see here I have disk reads at 193171116. I did a select from sys shared memory profile, and I have the same number. Now, this was an accident, I'll tell you, because they're both very dynamic and they continually change as things happen on the database server. So the fact that I got the same number here was a pure accident. Now, you can actually see how the SysMaster database is created. Informix gives you the SQL code for it. So let's take a look at the sysmaster.sql in the Informix.dir etc directory. This is the SQL code that creates the SysMaster database. And it looks at the beginning like they're normal tables that it's creating. What it does, if you look through the script, is it creates tables, then it drops them after it's saved the information about those tables off, and then repoints them directly to shared memory. So there are a few real tables, but most of them are views into shared memory, or peeks as I like to call it. There are also two other things here. One other thing called build SMI. And this is a shell script that Informix uses to create the SysMaster database. And I want to point out one thing. You notice this is run every time you do an upgrade. The first thing it does right here is it drops the SysMaster database if it exists. So when you do an upgrade, the old SysMaster database is going to be dropped. That's why you don't want to save any of your own scripts or monitoring tools in the SysMaster database. They'll be gone when an upgrade happens. And then it runs the script we just looked at. And it creates a SysMaster database. There is also some great documentation on the Informix documentation website on the SysMaster database. If you go into the IBM docs for Informix, you can see it for a number of versions, and you can pick the SysMaster database there and look at it. So what does the SysMaster database contain? It contains server information, DB space and chunk information, database and table information about all the users running right now and all the current SQL that's running right now. Now, it's dynamic. As soon as a user is disconnected, their data is gone from the SysMaster database. Now, performance on the SysMaster database is usually great because you're reading views from memory, except for the views that actually have to create tables. Some of these views are very complex, and one of them, syslocks, is a six table join. And if you have 1 million locks, that's going to create a 1 million record temp table for you to query. That can take a bit of time. Also, if you're in the middle of a checkpoint, some of the SysMaster tables may be held up because they can't create the temp tables you need to see it. So there are some caveats there to the performance. It does not lock anything. That's the key thing here. Now, you also can't update the SysMaster database. You can't do a DB schema. You can't drop it. And triggers, while you can create triggers, remember that they never execute because the SysMaster database is not updated with SQL. It's updated by directly reading values out of memory. So triggers never get updated. The isolation level is dirty read, and because of that, it's very dynamic, and you can go do a query and look at it, and then a second later, that data is gone because the user logged off or something else changed. So it is very dynamic. There's some undocumented tables in the SysMaster database, and it changes with each version of Informix. Now, the scripts here that I've presented, I've tested with 12 and 14. There was a major upgrade in 14.10 to the SysMaster database, but many of them work all the way back to version 7. That's when I started using these scripts. Now, a big disclaimer here is all the scripts are experimental, and so you use them at your own risk. I've tested them on 14.10 to FC10 and on 12 up to FC15. But the next release, version 15, when it comes out, there will be changes in the SysMaster database. So I have 58 scripts I'm going to share with you and talk about today. I'm not going to go over all of them, but let me show you where they are. You can go to my website and download them. And it's very simple. If you go to advanceddatatools.com, go to under free tech info, go to the SysMaster database, and you can do this right now while I'm doing the presentation. And then you can click here to download the latest scripts. After this talk, I'll have the PDF here too, so you can get the PDF right here. I also, on my website, have all the past presentations of the SysMaster database. Going back, I think the first one I did was actually in 97. The 99, I wrote a series of articles for Informix Tech Info. Anybody remember that? On the SysMaster database. So here's a quick example of why I find the SysMaster database very helpful. And this is one of the first scripts I wrote back in 96 or 97. I wanted to see how much free space was in each DB space. And onstat minus D would tell you that, but it did it by chunk, not by DB space. So I wrote a script to get the DB spaces, get the page size, calculate how much free space there was, and calculate the percent free for that. And it gives you a nice little summary of what's free. And this is an example of a script that's been running for over 30 years since I wrote it. One of the primary reasons for using the SysMaster database is to get statistics about how well your server is performing. And it's just like OnStat. It's the same numbers that are in the SysMaster database. And it's helpful to know when the stats were last reset, because that will give you an idea when you're trying to build performance ratios to see when they're last reset. I have a script here that I want to talk about that shows you when they're last reset. And it uses a very important undocumented table called sys shared memory values. This table's in the SysMaster database. There's only one record in it. Let's come over here, and I'm just going to do DB access. And I'm going to pick the SysMaster database and say select star from sys vals. And boom, I've got one record. But this has basic information about the boot time, when the stats were last cleared, what the current time is, and a number of key things that you want to look at. The page size for your initial buffers, whatnot. But this is really important because this tells you when on stat-c or when the server was last started. So you can use that to measure statistics. And I have a script here called uptime, server uptime. Let's go back here, and I'm going to do choose and come over here and find server uptime and run it. And so this tells me that here's my current time. The server was booted on the 6th of August, and the stats were last reset on the 6th of August. So the interval's been 6 days and 1 hour and 55 minutes, and here's the interval in seconds and minutes. This gives me numbers that then I can use to do how many IOs am I doing per second? How many IOs am I doing per minute? Now, when you clear the stats is really important. I'll show you that as we go through in a little bit. One of my favorite scripts is to calculate the IOPS that AWS uses. If you're moving to the cloud, this script will tell you how many IOPS do you need. Now, it gives you the average, not the max. So take this as the average you need. You need at least this amount of IOPS. So let me come over here and show you the script. AWS IOPS. And what it does is it uses the formula AWS uses to calculate IOPS, which is disk reads divided by the number of seconds plus disk writes divided by the number of seconds. And then disk reads bytes by disk write bytes gives you the throughput. So let me run this. And it says my stats in terms of uptime in seconds has been that many seconds I've been up. So my average IOPS is 214 per second. And my average throughput is, what would that be? 439, 502 bytes per second. Excuse me. Now that is the average, not the max. So that tells you when you're moving to AWS or to a new SAN, this is the average you need. You'll need more than this to hit peak max. Now, this is up 6 days. This server is up 6 days. If I come over here and just do an onstat minus, you can see it's up 6 days. It's in the middle of a checkpoint. If I do a U, I've got 1,024 users banging away at this server. It's just a benchmark server I'm using to run benchmarks on. So if I can do an onstat dash G SQL, I can see all the it's a mix of updates and selects and different things that are going on with about 1,000 users. But this is 6 days of time. Now, during the 6 days, I've had a weekend where I didn't do anything, and I had several days last week where I didn't do anything. So I would guess to say of the 6 days, 4 of them were idle days. So that's the problem with these averages. I'm including idle time. You want to, and I'll do this at the end and come back to it, do an onstat-c, run your benchmark for an hour to get the current. It'll give you a much better average time than you're getting just running it every 6 days. Or what I like to do is do an onstat-c every night, and then you get the actual usage during the day. Second script is the buffer turnover ratio. And this is one of Art Cagel's metrics. And if I come down here to server BTR ratio, and it tells me that my buffer turnover ratio is pretty good. It's 1.5 times per hour. Again, I'm using the same stat. And that's, again, partly very low because I've been idle for 4 of the last 6 days. If I was to do an onstat-z now, which I will in a minute, this is going to be a much higher number. I can also look at memory segments. Let's take a look at that. I have a script here called mem segments, server mem segments, and that tells me, now look at this, this is really bad. This tells me I have 57 virtual memory segments. Every virtual memory segment I get is a performance loss because now the server has to go between all these different fragmented sections of memory. And I can sit here and go through and see all the rows that were there. What I really should do, and this gives me the size, is create one initial virtual segment this size. And then I wouldn't have all these initial segments. I have a dashboard, and my goal in this dashboard was to have one script that would show me the performance of a server. Displaying key ratios. Now it's based on a union of 20 other SQL scripts. So let's take a look at it. It's called Server Performance All. And here it gives me the uptime in minutes, seconds, and gives me the total CPU time, the total disk I/O, how much memory I'm using, all the way down to how many sorts and chunks. Now, it's a union of 20 different scripts that I put together here just because you can. You can use SQL like this to query the SysMaster database. All the data comes from SysProfile, which is a very simple table that looks just at the same data onstat-p can't use. And so when you do onstat-z, this data is all zeroed out. And here's onstat-p, and here are my sys profile data. Disk reads is this same disk reads. Now I took these at 2 different times, so that's why they're different. Here's an example of when I did this on the same server but at 2 different times. This had been up 106 hours. This had been up 55 hours. But look at some of the ratios and how the shorter time actually may be more accurate. Now, if the shorter time had been when the server was idle, it would not be more accurate. What you want to do when you're looking at ratios is pick a busy time, do an onstat-z at the start of that, clear out your stats, and then run your benchmark or your busy time, and then at the end of it, get these ratios. So I call this a scientific method of performance tuning. And what it is you define the problem, and then you do research, you observe and measure. Then you build a test plan, you do an experiment, and you draw your conclusions based on the results of the experiment. And you may repeat this multiple times. When I teach the performance tuning class, and this is from many years ago, one of the scripts we take is a script that starts off taking 17 minutes. And we go through this benchmark ratio of performance tuning. And you notice one change we make is we increase buffers. It drops it down to 8 minutes. We increase shared memory value. It knocks off a second on down until after some SQL changes, we get it from 17 minutes to 21 seconds. And so that's sort of the goal of performance tuning. But it takes work, it takes steps, it takes measure. And this is the key thing, change one thing at a time. Many times when I teach a class, somebody will suddenly come up with a good number and I'll say, what did you change? They're like, I don't know, I changed 5 things. Well, of those 5 things, maybe only one of them really worked. You don't know which one really worked. And that's why it's very important to make one change at a time when you're doing performance tuning. Now, one of the scripts I do when I'm teaching a class is from an onstat-p, I take page reads, buff reads, page writes, buff writes, and I take the CPU time of the server. And this is important because this tells you how much time the database server was taking of the CPU. And if you improve the performance of things, and let's go back here, our CPU time went from 651.43 seconds to 9 seconds. That's a huge change. That means more stuff could run on the server without impacting the load. I worked with a client one time doing this, and just by focusing on CPU time, we got it so they could run their database on a cheaper hardware and cut their cost in half. That's what you want to look at. Now, I have a script called SysPerformance that measures these things, and so let's take a look at that. Server performance. And here's how it's done over the last few days. Now, what I'm going to do is make a couple screenshots here so that when we come back, we can compare this with, whoops. And let's do the AWS one. I'll just take these two and we can compare them. Yep, they got saved. Okay. So let me dive on with a little bit more on logs. And I want to show you something else here. I have 3 scripts for monitoring your logs. And the first one is checkpoint summary. And this tells you I've had 3 blocking checkpoints in the last 6 days, 17 non-blocking checkpoints since I've started. So if I restart it, if I have another checkpoint, I might do that. Let's just do an on mode -C to cause a checkpoint. Since I have 1,000 users on, this may take a minute, but then I'll see this become either a blocking or a non-blocking checkpoint. Okay, so let's take a look at this. The checkpoint finish that I just started, and now if I run it, it says I had 4 blocking checkpoints, whereas before I only had 3. So this is a key way of keeping track of your checkpoints. That means I had 4 times that the server stopped all users because of a checkpoint. So here's a checkpoint performance summary script I just showed you. Here's an example of another run where I had 8 blocking checkpoints and 20 non-blocking checkpoints. Now your logical logs, these are really important because these are used for not only transactions but also for HDR planning. You want to know how much data is going to be sent from the primary to the server. You look at your logs and your turnover ratio. Do you have enough logs, and are your logs too small or too big? My goal when I lay out a system is to have enough logs for 4 days. My second goal is to turn over my logs about every 12 to 24 times per hour. So let's take a look at our log turnover ratio on this. I forget which one is it. Statistics? No. Log usage. So this does have a cap of the last 7 days, and this tells me that I have 79 logs that it's been using. I am turning over 401 logs per hour. That's terrible. That to me means my logs are too small. And that's even with all the downtime I had in the last 6 days. And then it shows me my logs here. So I'm not meeting this goal. My turnover ratio is 400 times per hour. That's really bad. Do I have enough logs for 4 days? Let's take a look. And based on that, I don't. I don't even have enough logs for an hour. They're turning over 401 times. I only have 79 logs. That's not going to work out. So there's a lot of good stuff you can learn from the SysMaster database. Excuse me. This is a simple script I like called logs not backed up. And this just tells me that you should always have one log that's not backed up. If you have more than one log here, you've got a problem. And what users and what log position are they using? This will tell you, here are my users, and I'm running all this as Informix, so you only see one name there. But it tells me when their transaction began, the unique ID and the position in that log that it's taking place in. So let's just try running that right now, log position. So here are my users. Here's a session ID. That's when their log began. That's the position that it's in right now. A bunch of zeros. So those that are just doing selects won't show up here. Anyway, this tells you what logs are in use right now. Now, we're going to dive into DB space and chunks. Now, I have 3 scripts here, but we're only going to spend time with one of them. I showed you DB space free at the beginning. Chunk IO is almost the same as DB space IO. It takes place at the chunk level. So here's a script, and I'm going to run it. And it gives me 1 screenful per DB space. It tells me when the stats were last reset, because again, onstat-c is going onstat-z is going to reset the stats for your DB space IO. And it tells me how much read time, how much write time, how many pages per read, pages per write. And this is, I think, the key one, is what percent of the overall space is in reads and writes. So this first one is temp DB space. It's not used. Next one is the root DB space, and 10% of the system writes are going to the root DB space. That's a lot. That you should try and see 0 there. And I know the reason why that's happening is my physical log is in the root DB space. I need to move the physical log out of the root DB space to get that down to 0. The log DB space has 34% of my writes. So 34% of my writes are going to my log DB space. The data DBS has 43% of my writes. Now again, this is since I last started the server 6 days ago. The data 3 DBS has 14% of my writes. So based on this, it tells me the data DBS is probably the crucial DB space, and I probably need to move it to a faster disk if I had to. Temp DB space was 0, and that is wrong, and I know why that is. The server is initialized with no temp space defined. So DB space temp is not defined. If it had been defined, that would have been much higher than we see right now. So this tells you your page reads and writes per minute, and gives you a % of the total I/O, which I really like. Now let's take a look at some session monitoring scripts. And I've got 3 here I want to talk about. Session lock waits, who's waiting on a lock, session stats, and session wait list. And let me bring up my SQL, and let's go to, don't want to do that. Choose session lock waits. Now, this is an example where if I'm in the middle of a checkpoint, it may be blocked. And I'm in the middle of a checkpoint. So this script is going to be blocked. Okay, the checkpoint finished, and I got results back. It says I have 32 rows that are waiting on something. It tells me the user, the table that they're waiting on, the type of lock it is, and so this gives me all my locks. Now, you notice here, the reason it got blocked was I'm trying to create a temp table while the system is doing a blocked checkpoint. And when that happens, you will get blocked. So that's SysSession stats is another one. This just tells me the reads and writes by session. Sys lock wait is the one I just showed you. This tells me all the users waiting on a lock. And session wait list tells you if anybody's waiting on anything. So it's looking through your list of users and saying, is anybody waiting on one of these things? These are yes, no flags, and 0 means no, they're not waiting. 1 means they're waiting. And here I've got some examples, and just like here. Whoops, I didn't run it here. Here's an example. This one is waiting on a lock. Here's another user waiting on a lock. Several users waiting on locks. This last one here, this user is in a critical section of code. That means they're right in the middle of doing an update. Now, next, let's take a look at table performance. I really only have one script I want to show you here with a couple of little caveats. And okay, let's look at table performance. And I have a bunch of scripts here. A couple I'll point out is the table with sequential scans, the tables that have wasted space. The one I want to show you, though, is the table info all. And I want to show you a little trick I use because there's a lot of data in this script. And what I want to do is take that data into Excel so that then I can do stuff with it in Excel. So I'm going to open up DB Access, go into query language, pick the SysMaster database, hit choose, and go to table info all. Now you notice at the very top, let me do this in VI. So this is going to get a ton of information about table, and it is joining 3 tables, sys table names, sys tab info, and sys profile. And it's only getting real tables. If you look at the bottom, I'm not getting anything from the SysMaster database, from sys users, sys util, and only none of the system tables. What I'm going to do, I have this unload statement in a lot of my scripts, and that unloads the data instead of showing it on the screen. Well, let me show you what happens if I don't have that. I get this big long list, and it's more helpful, I think, to unload this and look at it in something like Excel. Or if you have Server Studio, that's a great way because you can see it in columns. So I'm going to run it. And it says 17 rows were unloaded. So let's exit and cat. And cat it. And here's the data unloaded. And I'm going to copy this data into an Excel spreadsheet I have sitting over here. I've used this before. And I'm going to go up here. This is very important to go up and do paste special and paste it as text. And because I've done this before, actually let me do this. Let me exit out of this, say don't save, and bring it in. brand new. Now let's put it here and save. Whoop. Edit, paste special. It still did it. Oftentimes, when you bring it in, it will put it all in one column. Then what you have to do is go over here to date and do text to columns and tell it to use the vertical bar to separate the stuff out. Now, I have my date that this was run. I'm missing a date. Interesting. There, now things line up. So I have a benchmark, database, the table, number of deadlocks, deadlock timeouts on that table. Now remember, this is since the onstat/z was last run. ISM reads, ISM writes, buffer reads, number of sequential scans on that table, page reads, page writes, and I have the percent of the buffers that were in that table. A lot of helpful data about this table. And so I'm going to leave you to explore the rest of these scripts on your own. They're pretty straightforward. I've got a script for the tables with the most sequential scans, which will show you sequential scans by table. Wasted space. This is when a row doesn't fill up a whole page. And so here's an example where I get 2 rows per page, but I use only, it's a 2K page, so 2048, but I have 644 bytes wasted. And in the whole table, that's how much wasted space there is. Not only is that wasted space on disk, it's wasted space in memory, because when it reads a page into memory, it reads the whole page, including the wasted space. Tables with free rows, and then I've got a couple of scripts to do extent sizing. Now, this is a key one, is index usage. What indexes get used? And I've got a script to do that. You can do an on check -pt database table, and it'll tell you the last time an index was used. But I'm more interested in how many reads to how many writes does an index take. The more reads the index has, the more efficient of it. Think of it. To create an index, you have to read 1 and you have to do 1 write. So if you have 1 read to 1 write, the index has basically only been used when you created it. So we're going to take data from 3 sources. Now, this has to get data from outside the SysMaster database. So we're going to take it from the SysMaster database, the sysadmin database, and then the system tables in each database. And we're going to join them using table partnum to avoid duplicate data. So here's a script, and this is what it tells me. Here's a table, here's the index name, it has 15 reads, 11 writes, a very small ratio. That's not a very good index. Now, I might know something about this index and say, yeah, maybe that's important. But normally, it's not good. This is what you're looking for. Here is an index that is used 677 times. So that's a great ratio. Here's another index that's used 46 times. That's good. That's not great. Let's go in and take a look at how this works. Now, because I'm going to pick the benchmark 2 table because this is a small one. And let's see, where's the index usage? So you have to pick the database it uses. It will join with SysMaster SysPT-Prof to get the I/O ratio. So here's in this benchmark 2 database, I have a table called state. I have an index. It had a lot of reads. That's a great ratio. Another one, customer table, a lot of reads, no writes. That's a great ratio. A product table, 14 reads, 0 writes. That's okay. The bills table, it has a lot of reads, but it's a 2-to-1 ratio. Now, I know this is a primary key because it's a system index. See, it has a space there at the front. That means it's a system index. So even though it doesn't have a great ratio, I need it. Now this next one, Bill's customer number, you do have to know your data here. This one has a lot of reads, some writes, a 4-to-1 ratio. But I happen to know, because I've been testing that, without this index, this script that runs in this database will take 40 hours. With the index, it's down to about 20 or 30 minutes. So even though it's not a great ratio, sometimes you need to keep them. Let's change databases. And I'm going to pick the benchmark 3 database and run this now. And so far, these look great. Look at these ratios. That looks great. That looks great. Here's one new order table that there are a lot of updates. That's a system-generated index, so I need it, but it only had 19 times. A ratio of 19. That's not bad. So this tells you how well your indexes are used, and most of these are used pretty good. Now, I have a shell script here to loop through all the databases, and it's going to run it. Let's take a look. What this script does is it goes to the SysMaster database and gets a list of databases. And then it cats that list of databases and runs that script for each database. So just as an example, okay, let me show you how it works. dbloop is a shell script. I need to pass it a parameter of the script to run, and it's going to now run that script against every database in the system. And there it is. Here all the databases on the system, and it's telling me the index usage for each database. We'll take a look at dbloop again when we talk about update stats, which is the last thing I want to talk about, is update stats. And there are a couple of scripts here that I think are important. I think update stats is one of the more important things a DBA has to do. One is to back up your database, make sure you can recover it, and then 2 is make sure it performs well. And one of the most important things to do is to do update stats. I have 2 scripts here to do update stats. One is to look at AUS and when did it last run. And so let's take a look at that. Here's an example of running the AUS last run. Let's go see on my system here. pick SysMaster, do choose AUS last run, and boom, only one thing was run, and that was on the 8th, which was on Saturday. I'm not doing update stats on this database. Now, I started the server 6 days ago, created these databases, and so they have no update stats on them. This is going to make it very interesting. Let's run the next script. I'm going to pick a database to run this next script on, because the next script is like the previous one. It's based on when a database is run. And let's see what the script is. DB update stats info. So AUS is not run, but there was some update stats. Here it says for the Benchmark 3 database, the customer table, medium was run on the 10th. On this column, on the first name, it was also run. This tells you when update stats was last run. And here on the history table, it was never run, except for low. And this is on the 8th. Here's a table that was last run on the 7th. So this will give you an idea of when update stats was run. Now, this last one I want to show you, and right now I'm not going to show it to you because I don't have anything running. I think all my users finished their benchmark. If I do it on stat-u, yeah, I don't have any users. But let's just take a look anyway. How do you know what's running right now and what the performance of what's running right now is? So I have a script called SQL cost explain, and what this does is take a look at the SQL way over here, and it tells you the SQL statement and what the cost was for that statement. Now, since I have nothing running except that script to look at what the cost was, that's what you're seeing here. But this will give you an idea of what is running right now and how much it cost. Now, there have been some instances, 1410 FC3 is one, where this may cause a cert failure. And that's because it's using a undocumented system table, sys control block list, to get that some data. And there may be a problem in some releases with that table. So just a caveat, test this on a development database with the version you have before you run it on production. Now, I think the best way to do this is run this once an hour and then save the results. And you notice the script I have here is I create a table, I insert into that table what I'm running, and then I look at a summary of data from that table. And it's always fun to get the top 10 most expensive SQL statements at your system. Running it once an hour, you're not going to get everything. And remember, you're only getting what's running right now. 1 minute after it's run, it's gone. You're not going to get it. If you want to do more in-depth SQL tracing, SQL Trace does that. And that captures the data in real time, and you can save SQL Trace data. What it does in this view, SysSQL Explain, there is a SQX cost. And that's what we're basing this on, is what was the optimizer saying this cost was. And it gives us the SQL statement. So you can see those two things there. And here's the internal table syscontrol blocks. There's a script. And here's an example where this insert statement ran 200 times while I was monitoring it. And that's the cost of that. That's a very expensive statement. Okay, I want to take a look at what the effect of onstat-z is on the SysMaster tables. And if you look here, I do an onstat-p, shows me my current stats. I am running a benchmark right now, which has about 1,000 users, and the server's been up for 6 days and 1 hour and 36 minutes is what that tells me. So I'm going to do an onstat-z. That will clear the stats out. And all my stats are 0. Now, because I'm in the middle of a checkpoint, it immediately picked up a bunch of disk writes. And I should see more disk writes. So let's let it run now. I've got these two benchmarks running, and we'll let it run for a little bit and then see what happens to the stats. Oh, before I do that, if I run this, now you notice it says the stats were reset on the 12th at just now. And I've only been up for 36 seconds. So I'm going to let this run for about half an hour, and then we'll take a look at the stats. Okay, I've finished the benchmark, and as you all saw, I ran onstat-z to clear out the stats. Let's rerun this, and this tells me it's been 2 hours and 1 minute since the stats were last cleared out. And let's first take a look at the, I'm going to run the Amazon AIS script. So this calculates IOPS, and it does it based on the number of seconds you've been up. And you notice it's quite a bit different from when I did this earlier. Let me bring my screenshot I made earlier when I recorded this. When I did it earlier, it had been up for 6 days, so the average IOPS was only 217 because I had 4 days where I wasn't doing anything. Now, since I have only been up 2 hours, the average IHOP is 3,187 times per second. Quite a bit bigger number. Same with the average throughput. It's quite a bit bigger number. So the point I'm trying to make here is it's very important that when you do an onstat-z to clear out the stats and then run some of these performance ratios, you do it at a busy time to get more realistic. This is much more realistic. 3,187 IOPS per second. And again, that's only the average. That's not the max. I'm sure in the 2 hours I've been up and running, I've had spikes higher than that. But that's the average. And this is a better number to use if I was going to Amazon to bring it up. So let's take a look at my other server stats. So my other server stats, I say I've been up 123 minutes. My CPU time is this. Let me bring over here. This is what I captured earlier when I did it. I've been up quite a bit longer. My CPU time was quite a bit higher. But look at the buffer reads and buffer writes. Again, quite a bit different in doing this. The last one I want to take a look at is buffer turnover ratio. Remember, when we did this earlier, it barely registered 1.5 times per hour. Now, it's in the 2 hours, it's turned over 24 times per hour. And again, this is a more realistic metric. Now, that's terrible. The last time we did it, it looked great. But that's because we had so much idle time in that average. Now, in looking at this in realistic time, 24 times per hour is a much more realistic number. So the point I'm trying to make here is when you get these stats is really important, and when you clear the stats out is really important to get good metric numbers. So that's my SysMaster scripts. I hope you enjoyed this. If you have any questions, please put them in the chat, and we will try and get them answered. Thank you for attending this session. Thank you on behalf of the IIUG for letting me do this again. I've had fun. It's good to see so many friends here, and I miss the old days in the Informix conferences. Anyway, if you're not a member, please go join the IIUG. This is the International Informix User Group, and the video of this will be up on YouTube at some point in the near future. And you can go look at the other Informix Tech Talks. Let's see if I can open it up in Safari. Yeah. So here are the other Informix Tech Talks that are out there on the IIUG website. So thank you and have a good day.